Our project contains 4 objectives: to create a network of actors and actresses based on the number of times they work in the same movie, perform PageRank algorithm on the network to get an importance ranking of the actors, create visualization for a subset of the network using Plotly and Network X, to further analyze the data using K-means clustering to find some key features of the successful movie. Firstly, we should do data cleaning, and in this part we drop an A and drop the duplicates for those and constant and characters are the same, and then we clean the actor dataset, turning off birth year from string to integer and get rid of the ones with missing birth year. This step is crucial for K-means clustering. After cleaning up the data, we use a for loop to go through the actor group and cast group to create a dictionary with movie ID and actor ID. And then at this part, we create a dictionary called Edge Movie Name to indicate the dictionary of the tuple containing 2 actors and the number of times they work in the same movie. And by using this dictionary, we can calculate the weight here, and then based on the weight to subset the Edge Movie Name weight dictionary to get the more specific and relevant dataset that we want. Use the actor I list to change the n constant into the actor name from this part, and then create a new selected cast list to contain all of the actor names. And based on all of this information, we can add nodes here by using the new selected cast list, and then add edges between each actors, and then create a page rank. After calculating the page rank, we use the page rank to draw the plot, and the network plot it looks like this. So basically, the darker the dot is, the larger the page rank they have, and we can see from this part they have larger page rank, and they have more connections with other actors.
Now let me briefly introduce the 3D network plot between different actors and actresses using Plotly. There are several advantages of this 3D plot compared to the 2D plot. So first of all, we can definitely move our cursor around onto each node to see which actor or actress the node is representing, and we can easily see the relationship between 2 nodes or even 3 nodes. The second advantage is that if we only want to inspect the relationship in a subgraph, we can easily do that by toggling around, for example, zooming into a specific region. For example, if we are only interested in the relationship between these 5 actors, we can move our cursor to rotate the graph, and we can zoom in to get a clearer picture. So if we don't want other lines to affect our understanding of this subgraph, we can rotate the thing so that this whole subgraph is completely isolated. So now let's turn our attention onto this pandas heat map created using Plotly. So in this graph we have 3 rows: the first, second, and third cluster, which are generated directly from the K-means clustering algorithm that we did before. There are 4 columns in the graph, which are the 4 different qualities or features that we included in the algorithm, which are namely the ratings of the film, the number of votes the film received on IMDB, the average age of cast, and the experience of the lead actor of the film. So let me briefly introduce the graph using the third column here. So from our report, we said that we computed the average rating of the films in the second cluster, and we found it to be the greatest of all of the 3 clusters here. So if we see and compare the average age of cast between the films in the three clusters, we can see the third cluster actually has the oldest cast members, while the second cluster has the youngest cast members. So this might make us tempting to say that second cluster having a higher rating but a relatively younger cast member, and we can say that maybe the cast average age is negatively correlated with the rating or the success of the movie. But this process might not be that accurate because we are only using about 4,100 of the entire dataset, which are a relatively smaller proportion, and we only included 4 features of the film. So in the future, we might consider taking into account more numeric features and maybe even categorical features, but we need to transform them in order to normalize them into a numeric feature. Moreover, the process here is a unsupervised learning. We might consider using supervised learning in the future, meaning we should pre-process the data into 3 labels: good, bad, and medium, so that might make the algorithm more accurate and more efficient.